Hi, my name is Richard. I'm a software engineer at Anyscale. I work on the team developing RayTune and other training libraries on top of Ray. Today, I want to share with you a couple of new exciting developments for RayTune with the Ray 1.0 release, and also some developments with the ecosystem at large. Let's quickly start off with the overview of today's talk. I know there are a couple of folks tuning in that haven't heard about or used RayTune, so let's begin with a quick overview tour of RayTune. We'll then be covering some of the new exciting features for RayTune in this new Ray 1.0 release. And finally, we'll be providing a broader perspective of the ecosystem that's developing around RayTune in the broader community. So let's begin with a quick whirlwind tour of RayTune. RayTune is a library for scalable hyperparameter tuning on top of Ray. It offers a variety of cutting-edge algorithms such as population-based training, Bayesian optimization, and hyperband. Similar to other state-of-the-art hyperparameter tuning solutions, it offers compatibility with basically any machine learning framework out there today. But there are really two features that make RayTune really special. The first feature is the focus on simplifying execution. With RayTune, you have the ability to launch a large distributed multi-GPU hyperparameter sweep with just less than 10 lines of code. In addition, due to RayTune's automatic fault tolerance, you can easily leverage cheap preemptible instances on any cloud. On the other hand, you might already be using one of the many popular, awesome hyperparameter optimization libraries out there today. These libraries offer great algorithmic improvements to the user. On the other hand, RayTune actually provides connectors to these optimization libraries, essentially as a middle layer between optimization and compute. This effectively allows the user to take advantage of these algorithmic advancements that are happening within these other libraries without sacrificing the scalability of RayTune's benefits. Let's quickly walk through the RayTune API so that for the newcomers, they have a better understanding of the flexibility and simplicity that Tune really provides. Let's start with a simple model training function. In here, we have a function called train model. It is defined by taking in a dictionary, which essentially encodes the hyperparameters. We then pass this hyperparameters into a function into an object called the convnet, which is essentially a neural network, and we're going to train this neural network multiple times while recording its loss. So to integrate with RayTune, you can take the reporting API from RayTune and add it to the training function where you might log the loss. So it's just a one-line call to inform Tune about the current metric of optimization. And this is really typical for any sort of framework that you might add to your training script during experimentation. In order to run a search, all you need to do is call tune.run, and you pass in this train model function, and then you can also specify a search space. Right now, our search space is a single value of LR equals 0.1, where LR is short for learning rate, a very popular hyperparameter. To perform a large-scale random search, you can first specify a search space. Here we've specified tune.uniform, which is a uniform distribution from 0.001 to 0.1. And then we want to scale out the number of evaluations, so we add a num samples argument equals 100, and this tells Tune to run 100 of these training jobs each with a different sample from the previously defined search space. Now, RayTune will then automatically parallelize the evaluation of these training jobs up to the number of cores on your machine or even across your cluster. Through this really simple, narrow API, RayTune is able to expose a variety of features, including automatic checkpointing and specifying all sorts of different powerful tuning algorithms, all within this simple entry point. So since the initial inception of RayTune in 2017, the RayTune mission and the team's mission has largely remained the same: to simplify and superpower the process of developing these machine learning models. So we've sort of tried to grow this community, and now Tune is really the joint work of over 100 contributors. It's also been deployed in production at numerous organizations. Over the last couple of releases towards Ray 1.0, we've been really working hard to improve the experience of tuning machine learning models using RayTune. Today, I'm excited to talk about 3 different directions we've been pushing for in this release, including improvements to optimization algorithms, improvements to the developer workflow, and finally, a generalized search space API. In this release, we're introducing a series of improvements to RayTune's optimization algorithms. One of our focuses has been population-based training, which is a hyperparameter optimization method developed at Google DeepMind, specifically and tailored towards tuning neural networks. So why focus on population-based training, or PBT? Well, we've shown that in a variety of use cases, from reinforcement learning to natural language processing, PBT has been one of the most effective methods for optimizing neural networks. And we've even shown that this can often be the case when using fixed time and cost budgets and comparing these different optimization methods within these constraints. You can check out the Ray blog for an exciting study where we compare different hyperparameter tuning methods on a popular data set and benchmark in natural language processing. In this particular release, we have 2 exciting new features. The first one is the ability to toggle the underlying implementation of PBT. So this allows users to toggle between a faster asynchronous method, which might be a little bit more unstable, but also a slower, more stable synchronous method. We're also focusing on reproducibility. So we're releasing a new mechanism for being able to reproduce and replay a particular training optimization run from PBT. In addition to these new advancements in PBT, we've also received a large number of community contributions improving our Bayesian optimization mechanism and also our wrappers for external libraries such as SIGOP. So that's it for optimization improvements. Now, as Tune becomes more and more ingrained into the broader ecosystem, it's natural for hyperparameter optimization to simply become another step in the practitioner's workflow. That being said, more and more users have requested features to make and help their routine become more interactive and iterative. And we're happy to announce some of these features landing in this new Ray release. The first critical feature towards this sort of iterative model of hyperparameter optimization is the ability to suspend and resume execution. We know that hyperparameter tuning can cost a lot of money and take a long time. This actually just simply means that the decision of launching a hyperparameter tuning job can itself be very expensive and time-consuming. Now, if you were able to, say, pause the execution of hyperparameter search, obtain the best trained model, and maybe resume it later, you're actually effectively able to de-risk this really expensive and really time-consuming decision of launching the job in the first place. So what that means is you can decide at some point that perhaps you don't want to spend any more money, but also don't need to fear that if you change your mind later and want to continue searching, that you're going to need to lose a bunch of progress. So we've actually had an experimental version of this particular feature in RayTune for a while. In this recent Ray release, we're expanding the scope of this functionality so that you can now also leverage search algorithms such as hyperopt and baseopt within the suspendable execution routine. This largely expands the utility of this particular functionality and brings users closer to a truly iterative model of hyperparameter tuning. Now, the second key feature towards interactive workflows is that users often find that some of their model training runs within the hyperparameter search fail. And it's actually very not ideal in order to obtain the results, to force the user to rerun the training job again or the tuning job again. In this Ray release, we're introducing a new capability to restart these failed training runs only with a single parameter. This allows the tuning process to much more easily tolerate failures and also speed up the overall analysis process for practitioners and researchers alike. Finally, for any experiment, you're going to want to visualize and save the results. Weights and biases helps machine learning engineers and teams optimize and collaborate on machine learning workflows and experiments. With this new Ray release, we're hardening our RayTune and weights and bias integration so that you can log and track experiments on weights and biases with just a couple lines of code added to RayTune. And it even supports our lib models out of the box now. The third feature I want to talk about in this release is a generalized search space API. As we mentioned before, RayTune offers a variety of different integrations with different search algorithm libraries. However, a dirty secret is that it's actually not quite easy to switch between libraries. If you want to, you would need to run through a bunch of different documentation and learn effectively a new DSL or domain-specific language every time you want to try a new algorithm or library out. On the screen, we have an example of a code snippet that is simply toggling between 4 different search algorithms, but it actually ends up exploding into more than almost 100 lines of code. So with this new Ray release, we're introducing a unified search space API. With this API, you can now try out and toggle Tune's different search algorithms by simply toggling one line of code. This frees up almost hundreds of lines of boilerplate. And here we have on the screen the same exact expression of the previous slide that we saw, which you would have to do in the previous Ray release. I'm really excited about this particular API because it truly strengthens the relationship between RayTune and other search algorithm libraries, where now you can pick and choose between all of your favorite search algorithm libraries without needing to write a bunch of boilerplate code and without needing to give up the nice features that RayTune provides. Now that we've covered the API changes, I'd love to spend some time talking about the broader, exciting ecosystem that's developing around RayTune. So in this section of the talk, let's cover some of RayTune's connectors for external libraries, a new integration with Hugging Face transformers, and finally, an integration for distributed training with Horovod on PyTorch. Machine learning developers use all types of different libraries, and we want to make sure that we can reduce the friction of integrating these libraries with RayTune. Obviously, this is capable today already, but we could actually, what we want to do was just simply provide examples and connectors for the variety of very popular frameworks so that users can easily switch from going from their single process code into going to a distributed hyperparameter search. In this Ray release, we're releasing a couple of connectors for MXNet, XGBoost, Keras, and PyTorch lightly. And we also have a variety of other libraries that we integrate with and provide connectors to, and you can find a comprehensive list on our documentation. In addition, we've also been developing and releasing a library called tune-sklearn. This is a scikit-learn compatible API for RayTune. So what's exciting about this particular library is that it provides the same exact clean scikit-learn interface, but also carries many of the benefits of using Tune, such as GPU support, search algorithm implementations, and early stopping. I think this is very hard to find out in the open source world today. We've provided also a variety of examples to integrate with popular scikit-learn facing libraries, including XGBoost, Scorch for a scikit-learn compatible PyTorch version, and Keras and LightGBM and so forth. You can check it out on GitHub, and please do and let us know what you think and start on GitHub. Next, I want to talk about our transformers integration. As you know, NLP is one of the most exciting fields today, and Hugging Face Transformers is one of the most premier open source NLP training and development libraries. RayTune has joined forces with Hugging Face in a recent release, integrating closely with its Transformers library to provide a hyperparameter search API. This allows users to easily leverage RayTune underneath the hood. Now, why is this important? Well, NLP is a field where hyperparameter search is really underappreciated. Even the flagship paper BERT executes a simple grid search in its paper. But now, with this integration, if you're a Hugging Face Transformers user, you can easily leverage RayTune's advanced features such as population-based training or distributed execution by simply adding a couple lines of code into your training script. And this allows you to really superpower and optimize your machine learning or NLP model at scales that you couldn't do before. Finally, let's quickly talk about distributed training. So you'll want to distribute training when your model or data becomes so large that the training times become infeasible. But distributed training is kind of a tricky problem. It's easy to set up in that there's many great frameworks such as Horovod and PyTorch distributed that allow you to take your code and go across multiple nodes without making many code changes. Now, on the other hand, maybe getting a proof of concept is easy, but the problem of distributed training gets actually quite hard because not only do you have to deal with the extra dimension of these infrastructure problems, such as failure handling and fragile timeouts, but also you have to deal with a whole new parameter space that only arises when you scale up. This includes setting different learning rate schedules or advanced batch size schedules, or even using some scale-specific optimizers, just to name a few of these different parameters. So now your model is going to require a bit of hyperparameter tuning, and specifically your model is going to itself be distributed. Without the ability to parallelize this parameter tuning, you're going to basically end up where you started, where the training time takes days to finish, and you're basically ending up with an infeasible training time for this model, for your model development. This is why it's so incredibly important to fuse distributed training with distributed hyperparameter search, and there really isn't a good solution for this today. In Ray 1.0, we're offering two versions of a distributed training plus tuning integration. We're offering a Horovod integration in addition to a PyTorch distributed integration. We also have a separate library for a separate higher level library for distributed training called RaySGD that you can check out on our documentation. This particular API for Horovod and PyTorch allows users to easily leverage multi-GPU and multi-node training as they might do already in conjunction with the distributed tuning capabilities of RayTune. And To top it off, this only requires just a couple lines of code. Again, this is really exciting because we expect this integration to provide huge value add to Horovod and PyTorch and Ray users alike, and we also expect this integration to improve and grow over the next couple months. So let's quickly overview what we covered today. We started off with a brief introduction of Ray Tune's capabilities and features. We then covered some of the exciting new features of Ray Tune as part of the Ray 1.0 release. And finally, we overviewed some of the new developments in the broader community in conjunction with Ray Tune. Now, if you're excited about what you hear and you haven't tried out Ray Tune today, I strongly encourage you to go ahead and run pip install Ray Tune on your laptop or your work machine and let us know what you think. Finally, I want to end this talk with a quick note about our monthly Tune community meetings. We're holding monthly meetings from people at Anyscale in addition to folks in the community around the world so that we can get some input on the direction and roadmap for Ray Tune moving forward. If you're interested in participating, go ahead and check out the link below. Thanks again for tuning in, and we're really excited to have you with us on our journey moving forward. I'm happy now to answer any questions, and again, enjoy Ray Summit. Thanks.